I guess that means we're starting. Hello, everyone. I am Colin Schultz. I'll be the host of our webinar today. I am the news editor at Hakai Magazine. And so in some capacity or another, I've been writing and editing and working on stories about the Deepsea hydrothermal vents, deep sea mining for about a decade before I started working at Hakai, where we cover it pretty regularly. I was writing about geophysics and earth sciences, a lot related to the deep sea. So I'm the host for a discussion that we'll be having today about deep sea mining, which is a sort of rapidly approaching, tense, complex issue. It's an industry that's on the brink of going big, and it's been a long time. It's a big mess, it's complicated, and we have some very excellent guests here today to help us understand it, answer your questions about it, try to make sense of the things. I have a lot of questions of my own. But so I'm the news editor at Hakai Magazine, and Hakai Magazine is a magazine, it's a popular science magazine based out of Victoria, British Columbia. It's a science magazine that's focused on coastal science and society. So we report on issues relevant to coastal people around the world. As we go through the webinar, if you have any questions we'll be having a Q&A session at the end. So if you have any questions, there's actually a Q&A tool located at the bottom of the Zoom screen. So you can put your questions in there and I'll get those. So before we kind of launch into the whole webinar itself, I want to set up a little bit what the goal and structure of this discussion will be, because it sort of is a discussion that will take place in two parts. The goal of the discussion is people have been paying attention to deep sea mining to various capacities. It's kind of burst forth this past summer as an issue that a lot of people are starting to pay a lot more attention to. And so the goal is to get everyone on the same page. Often you'll be reading stories about deep sea mining in the popular press. You'll read a story about Japan, or you'll read a story about the Mid-Atlantic Ridge, or you'll read a story about Nauru, or you'll read a story about the Clarion-Clipperton Zone. And you're like, this is deep sea mining. And the difficulty of this emerging industry is that while we call these all deep sea mining, they're not all the same thing. I will argue that there's functionally 6 different kinds of deep sea mining, and we're going to get into all of that, into some to more depth than others. So the basic structure of this is that we have our 3 experts here, and they'll help us understand sort of the who, what, where, when, why, and how of deep sea mining. And later, as we get towards the end of the discussion, especially in the Q&A section, we'll get into some of the more complicated questions, the shoulds and the coulds. But first, we just want to make sure everyone is, as you are in this discussion, as you're reading things, as you're seeing things on TV, you know that when someone says polymetallic nodules in international waters, that's a different thing than in a country's territorial waters or a hydrothermal event. We call them all deep sea mining, but they're not the same. They have different issues, they have different problems, they have different opportunities, depending on sort of where you sit on the spectrum of seeing this thing. So we have wonderful guests here who could not be better situated to help us understand this. We have John Jamieson, who is a Canada Research Chair in Deepsea Geology, and he's a professor at Memorial University of Newfoundland. He's going to help us understand, the geological aspects at play. He has some involvement in the policy side. He knows more about terrestrial mining, so we're going to have him to lean on for those sorts of questions. We have Verena Tunnicliffe, who is also a Canada Research Chair in Deep Ocean Research, and she's a marine biologist at the University of Victoria in British Columbia. She's going to help us understand all the biological dimensions of this issue, of which there are many. And our third guest is Klaas Willaert. He is a professor of law at Ghent University in Belgium, and he's an expert on the law of the sea. So a big part of this issue is policy, regulation, international diplomacy. So he's going to help walk us through some of those issues. So as I was saying before, if you have any questions, use the Q&A tool down at the bottom, and we'll work our way towards those at the end. So we're going to start off. The way that I want to kind of help us get our heads around this complicated topic is to start at the very bottom, and we're going to go up and out. So we're going to start with geology. That's what are these things? Why are we talking about this at all? And we're going to get into more and bigger consequences and issues. So the person who's going to help us go through the geological questions is John Jamieson, who, among his various other accomplishments, was about this close to being an astronaut. I don't know if you thought that was going to come up, but I thought that was cool. So I just wanted to, but so I said at the very top that there's 6 types of deep sea mining. There's 3 sort of main physical objects of interest when we're talking about deep sea mining. There's hydrothermal vents, polymetallic nodules, and cobalt-rich crusts. And I'd like to kind of go through them one by one. So very briefly, if you were writing a textbook and you were writing the little sidebar definition, what is a hydrothermal vent? What minerals are formed there? And how are they formed?
Right. Hydrothermal vents, basically, they are hot water springs at the bottom of the ocean. And so they occur where you have essentially volcanic activity at the bottom of the ocean. So mid-ocean ridges and subduction zones, which are we find in the South Pacific around all the volcanic islands down there. And so magma heats up seawater that circulates through the crust. And when that water is hot, it reacts with the rock and it extracts minerals out of the rock, essentially, and in particular metals. And that fluid ultimately makes its way back up to the seafloor. And when that hot water, that's full of dissolved metals, mixes with cold seawater, it produces a hydrothermal vent on the seafloor. And that mixing causes all of those minerals and metals to suddenly precipitate. And so you form these chimneys, or you can form mounds, and they're called black smokers. And all that black smoke is essentially tiny little minerals that have precipitated when these fluids mix. And so you get these accumulations of chimneys at various places on the seafloor. And that is your hydrothermal vent.
Perfect. And so, when we talk about mining, what really, sort of in the most general sense, how are they mined? Like, what's the physical process of doing that?
Right. So these vents essentially can be rich in copper, zinc, gold, silver. So, these are metals that are valuable to society, and they've never been mined before. The Japanese have tested some equipment to do this, but there's no single way to mine them, but essentially you have to break up the rock into smaller pieces and then transport that essentially to a ship, which it would then be transported off to land somewhere to a smelter to extract the metal from the minerals. So it's a sort of an engineering problem of breaking up the rock and then transporting it either through pipes as like a slurry, or you physically just lift with a bucket the rocks up to a ship. And this can be done at 2 kilometers, 4 kilometers, a kilometer. These vents generally form quite deep.
Okay, so the next sort of area of interest is these cobalt-rich crusts. Same sorts of questions, like what are they basically, and what does it look like to try to get them?
Right. So there are metals that are dissolved in seawater, very, very low concentrations, but seawater is full of all sorts of things, including metals like manganese, cobalt, copper, nickel. And certain conditions, these metals will slowly precipitate. And one of those conditions is the metals accumulate in deep water, and where you have seamounts, essentially underwater volcanoes, water will flow up the sides of these volcanoes, and they will accumulate as crust, which is, you could think of as almost like a concrete pavement, a coating on the rocks that form these underwater volcanoes. And this process is excruciatingly slow. It happens over millions of years, sort of, a centimeter every million years or something like that. So it's a very slow process. So around these seamount volcanoes, you get these crusts, these sort of pavements that slowly build up, and they're rich in, this time, some of the same metals like copper, but more so cobalt and nickel and manganese. So different metals from hydrothermal vents, they occur in different areas, but that's essentially what a cobalt-rich crust is.
Wonderful. Is from what I understand, that's very similar to the process that forms polymetallic nodules, the sort of slow accumulation and deposition of metals out of seawater onto some sort of surface or structure. So polymetallic nodules are sort of the other main thing. So if hydrothermal vents are sort of deep sea hot springs and the crusts sort of form on seamounts, where do nodules form?
Yeah, the nodules form essentially in abyssal plains. So the deep, flat part of the ocean floor. So the crusts and hydrothermal vents form in sort of mountainous areas on the sea floor, whereas the nodules form in the deep, flat plains, very low sedimentation rates. And the nodules are essentially little balls, or baseballs, or potato-sized concretions. And again, it's the seawater that has these metals in low concentrations, and very, very slowly they form these concretions that just sit on the seafloor as essentially they just look like a bunch of balls just lying on the sediment at the bottom of the ocean.
Wonderful.
So the mining of them is very different. You don't have to break anything up and crush it up. You essentially just have to pick them up off the seafloor and then again come up with some sort of efficient way to transport them up to the surface.
Wonderful. So you were saying that each of these different sort of targets of interest for deep sea mining, the vents, the crusts, the nodules, they have different component metals. There's different things in them. They form in slightly different ways. When people hear about deep sea mining, one of the things you hear a lot about is, we need these minerals for X. So that could be car batteries, it could be like, other sorts of renewable technologies, whatever. The argument is we need these metals for these purposes. So sort of these three types of targets, which has the most of the things that people are talking about when they talk about we need car batteries? Because if they have gold and silver and whatever, you can kind of find that in various places, but which one would be the one to go for that specific goal?
Right. That would be the nodules and the crusts. So the mass of the hydrothermal vents, those deposits, copper, zinc, gold, silver, we've got plenty of that on land. And it's well distributed globally. But that's not the case necessarily, especially with things like cobalt, to a lesser extent, nickel. And these just happen to be the minerals or the metals that are very useful for making batteries. And of course, batteries is one of the hot topics with renewable resources and electric cars and that sort of thing. And the companies that are pushing to mine nodules and crusts, they'll describe a nodule as basically a battery because it has a lot of the components that is required for a battery. In fact, most of the components in a nodule, there's very little waste because everything is actually quite useful from an industry point of view. So those would be the targets.
The other ones are less efficient, essentially, potentially.
Those are less efficient. It's just the need to go to new places to find those metals is not the same.
Right. So the next question I had was, what do we need the other metals and minerals for? But it sounds like the target is really the cobalt, essentially, maybe the manganese, some of these other things, less the nickel and the gold. And those are like bonuses in a sense, right? So.
Yeah, the narrative has kind of changed over time. When this industry first started developing, it wasn't so much about green minerals for batteries, it was more a commentary on mining on land, that we're finding fewer deposits. They're not as big, they're not as rich. We have to dig deeper. It's becoming more expensive. We have to push into more remote areas. There's a resulting more potential environmental damage.
Right.
Whereas the ocean, we can negate some of those concerns. But I'd say in the last 5 years, that has definitely shifted towards, we need things like nickel, cobalt, copper for a green economy. So that's sort of how the narrative has changed to where we are now.
Right. So the last question I have for you in this sort of setup phase of the discussion is just from a purely technological sort of, mining technology perspective, how close are these, how close is this industry technologically?
I'll give you a couple answers. Because it hasn't been done yet, it's really hard to say. I come from a family of engineers, and one thing I've learned in this industry is that if you throw money at engineers, they'll solve any problem. Any problem you could think of, they'll figure it out. It just takes resources to do that. I don't think the technology will ever be the limiting factor. But where we are now is there are companies who are testing technology for the nodules, and there are companies that are testing technology for the crusts and for the hydrothermal vent. So right now we're essentially in testing phase.
Okay.
So the concepts there's all sorts of different concepts. We haven't converged on here's one method that's probably going to work. People are trying all sorts of different things.
So soon, maybe they're working on it basically. So thank you. Yeah, thank you. So I think now we all know what deep sea mining is. So the next thing I want to do is kind of move out from the seafloor and just kind of go up a layer, which is where Verena Tunnicliffe is going to come in, and she's going to help us understand some of the, some of the issues around this aside from extraction. Then what, basically? So Verena Tunnicliffe is an expert on deep sea life, and I noticed I was reading that you actually have 10 deep sea species named after you. So obviously quite a lot of involvement in the field to have tens, I don't have any species named after me. But so this with you, I very briefly, the sort of sidebar version of the textbook chapter, go through the 3 different types of targets. We're going to spend a lot more time on the nodules because I know that that's the one that's sort of imminent in industry, it seems, and that you've expressed is sort of the one that you'd like to talk about the most. But so just very briefly, the hydrothermal vents that people are looking at and testing mining, what kinds of what's the environment like, biologically speaking? What's down there?
Okay, my first comment is that for all 3 of these deposits, there are special conditions in the environment that have led to the formation of the deposits of interest. And those same conditions are what have led to the formation of special ecosystems at those deposits. So for hydrothermal vents, what we find is that it is of an extreme habitat. It's a very difficult place to live because of the temperatures, because of all that nasty stuff and heavy metals and stuff spewing out, and lots of sulfide in the water, so not much oxygen. And it is, but on the flip side, it is a place, but because of all of that stuff spewing out, there is a source of energy that microbes have used to be able to harness the process to create organic carbon. So we call it chemosynthesis. It's an analogous process to photosynthesis. And what we end up with is a large primary productivity at hydrothermal vents in the form of microbial mats, lots of bacteria and archaea. That is the basis of a food chain in which there are very specific organisms that are able to deal with the extreme habitat and the extreme conditions They have evolved to live at hydrothermal vents. Probably 80% of them don't live anywhere else in the world but at hydrothermal vents. And they ultimately feed on, through its short food chain, on these bacteria that grow very rapidly at hydrothermal vents. Thus, the hot vents can sponsor a very dense biomass, highly localized right around the chimneys and the fluid sources.
Wonderful.
And they're spectacular and just beautiful to look at, as it was shown by the Hakai intro. With
Yeah,
the
I was just going to say our loading screen had the little worms on them and stuff. Yeah. So the cobalt-rich crusts, as we just learned, are on seamounts. So I know, because we've been reporting on this for ages, seamounts are places of like extreme biological density. They're very important. So what is sort of the biology of your average seamount? Obviously, it's going to depend on where you are in the world, but like, what is a seamount ecosystem like? Where the
your average seamount is really quite deep, but the seamounts where the deposits form tend to be the shallower ones. So the most of the deposits are above 2,000 meters. And when you get the shallower seamounts, that is where you get the formation. The same thing that the water is doing, depositing metals, it's also bringing food and bringing a lot of transport of goodies across the top of the seamount. And therefore, what we end up with is dense forests of corals and sponges, which then foster the growth of associated communities of other organisms. They become nursery areas for a variety of creatures, such as commercial fish stocks. And because there's food there, you end up with a water column that's also fed, and you get a lot of migrating species that use the seamounts. So most of the interest currently for the cobalt crust mining is in the Northwest Pacific, so over near Japan and Russia. And but unfortunately, that's a region we know the least about. And I would just finally comment that the seamounts in Canadian waters are now recognized to really be important parts of the marine ecosystem, and they are being, Fisheries and Oceans Canada is beginning to move them into a marine protected area.
Okay, so far, both targets of high, biological diversity, density, unique ecosystems. And you mentioned in the past that you think polymetallic nodule mining is sort of the one to talk about the most. And so one of the reasons that we're talking about all of this right now is because a Vancouver-based company called the Metals Company, which people who pay attention a lot will know that they were formerly Deep Green, and a lot of those people were formerly Nautilus. So it's a long chain of people involved in this industry based out of Canada. Canada is sort of one of the biggest players in this emerging field, along with Belgium, which is a great thing that Klaas is here. But so the Metals Company likes to say that the seafloor where these nodules are found is a quote, desert-like wasteland with limited life. And when people think of the abyssal plain, maybe that's what they're picturing. Is that true? Is it a desert-like wasteland with limited life?
Okay, I'll just presage my response with a comment that Canada as a state is not a big player in this.
Right.
It so happens the Metals Company is registered in Canada.
Right.
Is it a desert? No, not at all. We know lots about hydrothermal vents, relatively speaking. We know something about how seamounts work, but we know almost nothing about the abyssal plain, which is in the specific areas where nodules form. There's lots of abyssal plains in the world, but nodules only form in certain abyssal plains with very, very low amount of food coming in. And the reason the nodules are on the surface is that there's hardly any sediments coming down to cover them up. There's very little ocean production up above, so little food coming down. But the nodules themselves form surfaces for organisms, and the communities that have developed in this area, specifically, say, the Clarion-Clipperton zone, which is between Mexico and Hawaii. The animals, like hot vents, they have evolved to adapt to those specific conditions. The amount of research in this area, which is vast, is extremely small and really only started in the last 10 years. And this is the problem we face. Every single research cruise that goes out there, mostly I would say sponsored by state contractors. So these aren't necessarily, these aren't company contractors, but state contractors. They are finding that almost every sample they take, of course, something new comes up.
Mm-hmm.
So it becomes a beginning, growing understanding that this is an ecosystem specific to this area, as far as we know, and is adapted to living on or between nodules. Everything seems to be new. We're really having a hard time understanding how everything connects and how it works together. So what do you see when you look down there? Just lastly, you don't see a whole lot, except you'll get beautiful sponges here or a little coral over there. But most of the life is between and on the nodules and fairly
themselves, small. Yeah. So life on the bottom of the ocean is sort of famously slow. Animals live hundreds of years, they barely move, they're eating the sort of scraps that fall down in the marine snow. The nodules themselves grow incredibly slowly. I think it's like a centimeter a million years kinds of thing. So if the life is adapted to living specifically on the nodules. And at the Natural History Museum in London, they have a nodule that grew around a megalodon tooth. So this shark's been extinct for millions of years. And it's sort of like a snowflake. There's a nucleus and this metal sort of glom onto it. So if it's a megalodon tooth at the core of it, it's old, obviously. So if life is slow, nodules are slow, it's all very tenuous. If you go down and pick these things up, it's obviously going to take quite a long time. If ever, could it ever rebuild?
So when deep sea mining was first proposed back in the 1960s, it was thought these nodules were a renewable resource and they would bounce back within years. So you're right. They're gone forever as far as humans and the ecosystem is concerned. So that's removal of the nodules. A big concern for many scientists is that as you go through that area with these house-sized machines that are going to be vacuuming them up, the sediment plumes that are being put out, and also the tailings or the sediment is dewatered from the ships. This is crystal clear water. That all has to be disposed. And so that's going to cover up more habitat. No, this is a habitat is going to be removed. And we have to decide whether or not that's important habitat. Do we care about it? I've heard it said from ISA that, well, we can afford to lose a small fraction of the seafloor in this process.
Sorry, I just got distracted by looking at the Q&A questions. But so that, I mean, that sort of feeds into the sort of the last two questions that I had for you. You mentioned, the sediment plumes and this kind of thing. There's something that you catch on to when talking about climate change and these sort of systemic shifts in planetary processes, right? So my previous writing was a lot about Earth systems and geophysics. So it's sort of a sort of big brain question that we probably don't have an answer to, but is there a potential with this sort of deep sea mining, sediment plumes kicking up things, affecting carbon cycling, whatever, to disrupt any sort of large systems, currents, you know, the El Nino is in, I mean, that's extrapolating and whatever, but you get the idea, like, is there this risk of like a tipping point or like disrupting something that maybe we're not even thinking about?
Yes, you raise an extremely good point, which has been many of the worries, is that the fundamental ecosystem processes which is the ecosystem service. What is the ocean, this deep ocean, doing for the rest of the health of this planet and our own health? And this is a very difficult topic to argue because we don't have the information.
Mm-hmm.
So, but we can say that when it comes to climate change, one of the huge services the ocean does for us is absorbing 2/3 of the excess carbon dioxide we put into the atmosphere, goes into the ocean. It's taken up by the little creatures on the surface, and that carbon goes down and is buried in the deep sea sediments. And that's the service that the deep sea provides, and all the microbial ecosystems in the bottom, the little creatures that are burying. Now, so this is something that is a big concern because of, okay, and then what connects back up? How are these bottom ecosystems feeding back up to the surface, and what nutrients might be going back, or just the organism larvae themselves going up and feeding fish that we're going to rely on. Mm-hmm. So you can draw all these pictures, but we have from the nodule areas, we just have very little data, but some experiments that the Germans have done have shown that even disrupting a small amount of sediment, you change the behavior of the microbes in that sediment for years and years. So 30 years later, they see that the microbial populations have not come back and doing what they normally do in the deep sea, just by turning over the sediment.
Mm-hmm. So there's a lot of unknowns, and there's a lot of potential effects, downstream consequences. There's stories that people, I mean, I'm trying to keep us a little bit on track on time, but there's stories about worries about fisheries, say where this plume goes. Do animals rely on this? How could it spill over into large effects? And it's hard to say because we just don't know. That's sort of the crux of the whole dilemma, at least from my understanding.
It can be very difficult to put out a we don't know argument to convince people. And so we try really hard as scientists and biologists studying these systems to talk about what we do know, to try and just when you're talking to, say, delegates at the International Seabed Authority, you try to talk about what we do know in the systems, because nobody wants to hear about what we don't know. However, that is a fundamental factor in this case.
Because if you're going to start something, you'd like to know. So, I mean, you mentioned the ISA there, which obviously bridges us over to our next level of discussion, zooming out another rung on this ladder of deep sea mining. And so the person who's going to help us walk through and understand some of these policy, regulatory, structural decision-making processes is Klaas Willaert. So Klaas started his career in piracy, not being a pirate, but studying pirates. But since then, he's used his expertise on maritime law and shifted into studying the legal dimensions of deep sea mining. So with John and Verena, we really focused on sort of the three forms of deep sea mining, you know, the vents, the crusts, the nodules. With you, I want to add those other two aspects to give us our 6 types of deep sea mining, which is, so we're going to look at how the laws and regulations change depending on where the mining is taking place. And there's sort of 2 broad categories of where this could take place. There's international waters and a country's territorial water or its economic exclusive zone. So in the same way, very, very briefly, what is international waters? What is an economic exclusive zone?
You indeed, that's very good to point out that there are basically two kinds here, legally speaking, because we indeed have zones that are within national jurisdiction of coastal states, and we also have, well, those zones that are beyond national jurisdiction. When we're specifically talking about the deep sea beds and the subsoil beyond national jurisdiction, we're talking about the area. So the area with a capital A as defined in the Law of the Sea Convention of 1982. When we're within national jurisdiction, indeed, we have the territorial sea of the coastal state that can extend up to 12 nautical miles from the coastline. You mentioned the exclusive economic zone, but what is very important also here is the maritime zone called the continental shelf. This one differs, the legal continental shelf differs in some way from the geological concept, but this one can extend as well, you could say as a default legal continental shelf, you could extend it up to 200 nautical miles from the coastline, but it is possible to go even further. And this is all based on well, some quite technical criteria. And then you could extend the continental shelf even further, but of course with also an absolute maximum that is there. So these are the two types, you could say, in legal terms. And of course, this is accompanied by a totally different regime.
Right. So that's where I'm wanting to go with this. So within a country's national water, let's say Canada wants to mine the Canadian deep sea, we just said. So in that sort of situation where you're dealing with a country looking to mine its own territory, who gets to decide whether deep sea mining goes forward?
Well, simply said, it's all in the hands of the coastal state. So the coastal state in its territorial sea, of course, it has its sovereignty, and within the exclusive economic zone. So this most of the time coincides as a zone with the continental shelf. There it can also exercise exclusive sovereign rights to exploit the resources there. So they can decide on the legislation. However, there are some international limitations, of course. So all states are bound by a general duty to protect the marine environment. Of course, this is quite an abstract obligation. And also, but this is already a little bit more in detail, when the extended continental shelf, so beyond the 200 nautical miles, would be mined by a coastal state, then they would also be obligated to contribute to, basically provide contributions to the International Seabed Authority, which would then be distributed among mankind as a whole. So you have some international interference within those national regimes, you could say.
Right. But largely, if Japan wants to mine Japan, Japan has to ask Japan. They don't ask everyone, what do you think? In international waters, obviously, it gets a little more complicated. And that's where the regulations, which are currently being developed and devised for when and where and how mining in international waters can take place, they're currently under development by a branch of the United Nations called the International Seabed Authority, which we've touched on a couple of times here. So in the sort of one paragraph summary of what is the International Seabed Authority, who is the International Seabed Authority, like who's involved in it?
Well, the International Seabed Authority, the member states are basically all the same states that are a party to the Law of the Sea Convention, also others who would have acceded. It is an intergovernmental organization. It has its seat in Kingston, Jamaica. And like you said, they are the ones responsible for adopting regulations, rules, and procedures on deep sea mining beyond national jurisdiction. So they already have issued regulations on prospecting and exploration. So you could say that first two phases of deep sea mining. But the exploitation regulations, so real commercial mining and extraction of the resources, these regulations have not yet been adopted. This could happen sooner rather than later, but up till now, this has not been the case. So the mining code is not completed yet.
So the ISA is this group of, it's a branch of the UN, it's made up of member states, and they have the decision-making power on allowing exploration permits in the future, allowing exploitation permits, devising the regulations. Who gave the ISA this power? Like, where did they get the power to basically legislate most of the planet, in a sense?
Yes. Then we also have to get back to the 1982 United Nations Convention on the Law of the Sea. So in this convention, you have the whole legal basis for this organization. Of course, we need to mention that there's also an implementation agreement that was adopted in 1994 and that changed, and adapted a number of provisions and rules of Part 11 of the Law of the Sea Convention, which governs the international deep seabed, the area. But so there you can find the legal basis. There, the whole mandate of the International Seabed Authority is vested. So
and then, sorry,
they have quite a broad mandate, and this has already led to questions, of course, of how far this can go.
because it's basically this one group that's deciding the future of this whole thing. How do they make their decisions?
Well, you have a number of organs within the International Seabed Authority. Of course, you have a secretariat. You have a council, which is basically, you could say, more or less the executive branch. You have the assembly of the International Seabed Authority, which is basically the legislative branch, like the parliament, you could say. And the council also has a sub-organ, which is called the Legal and Technical Commission, the LTC, which is a body of experts. And they are actually the ones that in practice have quite a lot of influence on both the regulations, the development of the rules, of the procedures, but also on those applications, because these experts are the ones that are going to give a recommendation to the council, and this is not often, of course, overturned. So the LTC has a lot of influence, and the council then takes a lot of the important decisions, but on those recommendations of the LTC.
Mm-hmm. So it's a small committee within the ISA that kind of vets the proposals, and then it goes and it tends historically to whatever the LTC decides tends to kind of happen. It seems like. So yes. John said earlier when I asked him, technologically speaking, deep sea mining is like not here, but it could be here if the money was put in to develop it. It could move along. The policy side, it's the coastal waters, international waters split. But so for a country mining the deep sea in its own waters, it could basically start tomorrow if a country decided to. Is that right?
Yes, indeed. So we have a number of countries that have already quite advanced legislation in place, some even quite very recent legislation also. So there, of course, the legal framework is there, which is not the case in the international context beyond national jurisdiction. So in the context of the ISA and the area, we still have to wait for those exploitation regulations.
Right.
But of course, in national jurisdiction, you also have, it depends upon the countries, you also have a number of obstacles still.
But it's largely up to the country itself. With international waters, we know it's up to the ISA. And a thing that happened over the summer is that the Republic of Nauru partnered with the metals company, that Vancouver-based company, and they triggered a clause in the ISA's regulations called the 2-year rule. And this is a trigger. Maybe we'll get into why it exists as a trigger later. I haven't looked at the Q&A questions, but it's a trigger that gives the ISA 2 years to finish writing the rules, or companies can go ahead with whatever the rules are at the time that the trigger runs out. So after this 2-year period. So does this mean that we have 2 years, like from June when this happened, before like the machines are on the seafloor, or is there another layer that comes after that? Like, is it 2 years until it starts, basically, or is there more?
It will still, even after the exploitation regulations would be adopted, we also have a whole wide array of standards and guidelines that need to be adopted, and they aim to also adopt these, well, at least you have different phases, but at least a lot of them will already need to be adopted also when the exploitation regulations are adopted. But then I assume it will still take some time. So this will not be, I think, the actual start. But of course, the ISA is under a lot of pressure with that 2-year rule that has been triggered. And there's also a lot of uncertainty. Legal uncertainty, because like you said, the mining code needs to be finished within 2 years' time. So June 2023, that would be the end of June 2023. If this is not the case, we're getting in a quite risky, dangerous situation, because then if there is an application for exploitation activities, the ISA would, despite not having adopted exploitation regulations, would nevertheless need to consider an application for exploitation activities, and it would need to, if positively advised, would need to provisionally approve these applications, but also on the basis of, well, the relevant treaties, but also on the basis of provisionally adopted regulations and rules. And so these are those two provisionally approve that process, and the provisionally adopted regulations, it's quite unclear on both counts what this would exactly entail. And that is why it's quite risky if we're getting in that situation.
So I have a couple more questions for you, and then we'll get to we've already pushed a little bit long, but I have a couple questions before the Q&A. They're kind of questions of legal responsibility, because from my understanding, a lot of this stuff, when you're talking about countries and contractors and sponsoring states and international corporations, it gets kind of messy. So when we're talking about legal responsibility, you have a sponsoring state like the Republic of Nauru, and you have a company like the metals company, and they're going to be mining in the Pacific Ocean, right? And let's say something goes wrong. You have this sediment plume, it wipes out, whatever, something happens. Who's responsible? Is it Nauru? Is it Canada because it's the company's centered here? Is it who's responsible if something goes wrong?
Well, that's a very good, but also quite a complex legal question to answer, because indeed you have that concept of a sponsoring state. And that sponsoring state basically needs to ensure compliance by the entity it sponsors. But there was an advisory opinion in 2011 by the ITLOS, the International Tribunal for the Law of the Sea. And the Seabed Disputes Chamber, in that advisory opinion, basically stated that, well, they need to take those sponsoring states need to take all necessary and appropriate measures to ensure compliance with the treaty, but also with the contract. But they also stated that when those measures have been taken, those measures that are reasonably appropriate within the legal order of that state, that they cannot be considered automatically liable or responsible for any damage or any liability caused by any acts of the sponsored entity. So if they took all necessary and appropriate measures, they should, in principle, be in the clear. Although it is, of course, very much the question what those necessary and appropriate measures would need to be then.
Right. So in our not quite hypothetical scenario, can a government, say the one in Canada, do they hold any authority or power over companies based out of them operating in foreign waters on behalf of the sponsoring state? So let's say deep sea mining is politically unpopular in Canada and Canada bans deep sea mining. Would a Canadian company be able to conduct this business? What power does a country have over a company based out of it if that company is partnered with a different country?
Well, I think purely in terms of international law and in terms of the international deep seabed regime, there's not really a bond right now, for example, between the metals company and Canada, because then they will just look at the sponsoring state. In this case, the metals company, has obtained 3 contracts within the area. And so they would need, if they look at a state, they would need to look at Kiribati, at Tonga, and at Nauru, the 3 states sponsoring those contracts. And that is, of course, a bit problematic, I would say, because here, those sponsoring state, the whole concept of the sponsoring state has eroded a little bit because of the fact that the ISA does not look any further than the incorporation of a company, which might be, like in this case, a subsidiary of a company based in another state. So that is quite problematic.
So it sounds like if the sponsoring state takes all required steps, they're not responsible if something goes wrong. And the country that the company is based out of, if something goes wrong, they're not responsible if something goes wrong. So I guess the company is responsible if something goes wrong?
Yes, they would, of course, be the first one to look at. But the whole liability question is we talked about uncertainty also in the biological context and the impact. Well, here in the legal context, there's also a lot of uncertainty. What would happen if there is an accident, or if there is, major damage, of course, to the environment or biodiversity because of just a normal operation. So that is still quite complex and quite hard to answer in legal terms.
Right.
But the sponsoring state carries a very big responsibility there, although it is questionable whether they would be held accountable.
I just have one more question, then we'll open it up.
So Verena was also.
Yeah, I just want to ask my question because it flows out of what we were just talking about, which is that in other sorts of maritime activities, shipping, fishing, whatever, you have this dilemma, this issue called flags of convenience, right? So right now, if I buy a ship and my ship is subject to laws, I get a flag from a country and that country is responsible for legislating, enforcing how I behave, right? So, and I'm subject to the laws of the flag whose country I am flying. Some countries they'll sell their flag, but they're not particularly interested in enforcing anything. So that's what people talk about when they talk about the problem of flags of convenience. Is that you can get their rules, which maybe are better for you, they're more lax, whatever, and then you're not really subject to enforcement because the country's not interested. So what is preventing deep sea mining with this sponsoring state, corporation, whatever, from turning into a kind of flags of convenience situation?
Well, I think with regard to the normal motives for a flag of convenience in shipping, there we're mostly talking about indeed like less strict regulations, less strict standards and no enforcement. I do hope that this would not be the main problem when we're seeing the same phenomenon among sponsoring states. But what I'm mostly worried about here in this context is that we have certain sponsoring states, for example, Tonga, Nauru, that are sponsoring, well, basically a subsidiary of the metals company. So they're basically sponsoring a company that is based in a developed state. And nevertheless, that company based in a developed state will have access to privileges that were attributed to developing states. And that's where the whole system, the common heritage of mankind concept gets eroded, is challenged, I would say.
Mm-hmm. I had a question about that. Let me just pull that up. Also, yeah, we need to get to some of the Q&A questions. I'm being told to kind of push along a little bit. So you were just mentioning the common benefit of humanity. How, like, what is that as a concept? Oh, well, I guess we'll do that question and then yeah. So this idea of the common benefit of humanity, the ISA is mandated with regulating the deep sea, international waters for the benefit of humanity. That's one of the wrinkles that's sort of, causing a lot of these uncertainties with the development of the regulations. How is that? How does that play out? Like, am I going to get $1 every year in the mail as like my share of the deep sea mining?
Well, first of all, the common heritage of mankind, the whole concept, the principle is well, it has a lot of components. So participation of developing states, promoting that, for example, is one aspect. But that equitable sharing aspect of the proceeds of deep sea mining within the area is definitely also one of them. So activities in the area should in principle be carried out for the benefit of mankind as a whole. And that is why the payment mechanism that still needs to be set up, and also the distribution mechanism that would then equitably divide and distribute that revenue among all member states, that would be a very important aspect. And of course, if I say distribute, you also have, it is also important there that developing states would have some kind of priority, of course, would not be equally distributed among all member states. There would be some priority for developing states. And that system is just like the exploitation regulations as such, still needs to be set up. So it's also, I'm quite curious to see how they will shape this regime, this mechanism, and it will be, well, we will have to see then if it really achieves that objective of well, making sure that those activities are carried out for the benefit of mankind as a whole.
Mm-hmm. So there's a lot here. I want to get to some of the questions that readers have had. We've kind of I'm already way over time and I'm sorry for that. There's just a lot to talk about. We've laid a foundation. I think everyone is on the same page. We understand what deep sea mining is, how far away it is, what's at risk, what's up in the air, these sorts of things. One of the questions is sort of this discussion of batteries and that kind of thing. And this is sort of, whoever wants to answer these questions. How, if we're talking about nodule mining, let's say, how much of the area would we need to mine to get like 50 years worth of batteries, like to help us through the climate transition phase that people are pushing for, of the sort of total, like what proportion are we looking at?
Currently, in the Clarion-Clipperton zone, 20% of the area is in contracts, and another 20% is reserved for other people coming in. And these are the prime areas where there's nodules. It is actually incredibly difficult to make those projections at the moment. And we seem to be riding a whole lot on the projections put out by the metals company, a few sources. And I would want to put in here that half of the contractors are actually state entities, and they're worried about their own supplies of metals within their own states. And it's not about a company that's trying to make a whole lot of money. The metals company, when it put its SPAC out, its offering in New York, claims that a lot of its profits are going to come from nickel. And the second most will be from manganese, in the manganese nodules. And so they're looking at a 30-year timeline. That's how long the contracts are. But it's all predicated on assumptions about batteries, and battery requirements are likely to change.
Well, that actually leads into another question that is here, which is, recently large technology companies, Tesla, Samsung, et cetera, have announced a shift away from cobalt, which is one of the kind of core things. They're shifting away from using cobalt batteries into other types of batteries. Given that, does that sort of change the math on whether or not this is a needed thing, or was it ever a needed thing? I think, John, we haven't heard from you in about 45 minutes. I don't know if you want to talk about, you said the other kinds of minerals are quite abundant on land and evenly distributed, and cobalt kind of seems to be the thing that's really concentrated in these nodules. If we're not looking for cobalt, there's still the same sort of impetus.
Oh, well, in the end, this is the mining industry. So it's supply, demand, and economics, essentially. Yeah, if we could figure out iron batteries, and people are trying to do that, then the demand for cobalt will go down. We're not there yet. And so for now, people are building a lot of cobalt batteries.
Right.
Cobalt is an interesting one because the amount of cobalt that we think lies within nodules on the seafloor is, it's 4 or 5 times the total amount of cobalt that we know is recoverable on land right now. So in terms of just amount of metals, excluding, how do we do it and what are the environmental effects, just amount of metals on the seafloor, there's a lot of cobalt. Where do we get our cobalt right now? Well, most of it actually comes from the Congo. And so it's not necessarily the most secure source. And there's a lot of accusation of, for example, child labor being used in the Congo. So countries or companies wanting to pull away from cobalt doesn't necessarily have to do with the seafloor at all.
Right.
It has to do with security of supply and projection of demand. And the battery technology is moving very quickly. So, there's possibilities for iron and other things to replace cobalt, but for now, cobalt is what we need.
Mm-hmm. That you sort of, you were mentioning Congo, and, there's sort of various different arguments for, especially coming from some of the proponents of deep sea mining and sort of counter-argue, whatever. It always seems billed as sort of a least worst option. And I don't think a lot of people are pushing for it as the best option. They're sort of pushing for it as the least worst option. And I know, so Verena, we were talking before this that you're looking into sort of a comparative analysis of terrestrial mining, deep sea mining, these sorts of things. So one of the questions that people have is, how do they compare, right? How should we be thinking about comparing these two things? What are the metrics that we'd be looking at? And do we have any, insight into whether one really is maybe more environmentally friendly or not, or more socially just or not? How can we start to begin comparing these two very different processes with the same kind of outcome?
Incredibly difficult to do. And there have been some publications out there, but we're talking about an industry on land that has a 4,000-year history and something that hasn't started and that we don't know what the effects are. And so it is incredibly difficult to do a scientific comparison, which I'm part of a group that's trying to do that. And we're finding it's apples and oranges, apples and oranges. And so, and we're very skeptical of some of the published comments that have been out there because we're seeing how difficult it is to do. So one of the things that's so easy to talk about is what we can see on land, and versus what we cannot see at all in the deep sea and don't know what the connections are. So it really depends. So to try and be succinct, to try and compare the concept of biodiversity and function lost in an ecosystem that is essentially pristine versus the continued losses in ecosystems that have been impacted by humans for thousands, well, hundreds at least, if not thousands of years. And it's a matter of partly a value judgment. And I'm not going to give you an incredibly clear answer at the moment because the team is still trying to work on how to make that comparison. The lack of data versus disparate data is really hampering that comparison.
Mm-hmm. So, you know, there's some sort of themes in the questions that I'm going to try to interpolate a little bit, which is, you know, we talked about the sediment plumes, we talked about the potential for sort of pushing systems around. Do we know the connection between the deep sea ecosystems that would potentially be or would be disrupted by these processes to the larger ocean ecosystem? Like, would there be ramifications up the food chain, higher in the ocean, closer to shore? What would, you know, the kinds of effects that we would feel on, say, fisheries or biodiversity?
If you want a finger on an immediate effect, that's probably going to be quite difficult, but it's certainly all of these mining actions are going to affect the interactions of the deep sea with the surface, which comes through transport of food and materials back and forth. It will also affect the transport of toxins in the system, especially through things like the sediment plumes. One of the things that many people scientists are really worried about are the cumulative, the compounding effects of adding mining onto the fishing pressures and onto the climate change pressures. So think about, say, seamounts in particular, already under huge fishing and climate stresses. As temperatures go up, oxygen goes down. And the deep sea, as you noted, a very stable, very slow system, which just needs a small change in temperature and things get really badly put off. Migration patterns of large mammals are likely going to be affected, especially by the activities. So just a few examples.
So we have an interesting question about regulation, Klaas, which is, and the rules are not set yet for the mining code and the exploitation guidelines. Maybe there's some precedents that would lead us to an understanding of this question anyway, which is that, let's say a company gets a permit within, like, let's say 5 years, and they have their permit and they are given the go-ahead to start mining. Will the rules and regulations that they're subject to evolve over the lifetime of that endeavor? Or is this sort of like a grandfathering thing where, like, well, we were given this permit? Are people talking about, like, setting the rules up to because there's so many unknowns, to evolve as we learn more, if we're spending time down there, to adjust?
I think that would be quite desirable, of course, to make sure that if the situation or the knowledge of, changes, that regulations can also change with it. But of course, when a company, for example, or the state applies for a plan of work to the ISA and this gets approved, then this is adopted in the form of a contract. So then you have a contract between the ISA and the other entity. That can be a state, can be a non-state actor. And it is, of course, very hard. Once you have that contract, you have specific rules also embedded in that contract. And this cannot just change like that. So that would be very hard. And the regulations that are in place at that moment would be the ones governing those activities. And of course, I think if you would ask those contractors, they would also be saying that we started our operations under those conditions. And so these are not allowed to change anymore. Of course, it would be certainly in a situation that we're in right now, when we're not yet at a point where we can say we can map the whole impact. It would be wise to be able to make sure that those regulations that are applied, that those can change. But this would, in legal terms, would be very unusual.
So the last question that I have here, I think we'll go to John, just we haven't heard you again. You know, we were talking about the nodules and the crusts, but we started this whole discussion talking about hydrothermal vents. And while most of the effort right now is on nodules, because that's the sort of one that's pushing forward the fastest, it seems, people are still looking at vents and the cobalt-rich crusts. One of the viewers asked an interesting question about hydrothermal vents. We've discussed the role and the unique biota that live there and all these things. Are there dead vents? Are there vents that are no longer biologically active? And is there a risk of like going to get those ones and not, you know, ignore the ones where the worms are? Are there extinct, you know, the way that there are extinct hot springs? Are there extinct vents?
Yeah, that's an excellent question, and the simple answer is yes. So vents have a finite lifespan, and after a certain time, the heat runs out, or the fluid goes somewhere else, and they die, and they can no longer support those chemosynthetic organisms that Verena was talking about. And the way it looks like the regulations are evolving is that it may be the case, and it seems like it likely will be the case, that there will be a ban on exploiting the active vents. And so that leaves the inactive vents. So the problem is this: the way we find these deposits on the seafloor is by hunting out the hydrothermal plume. So you know, the fluid coming up and all that smoke we talked about, that spreads out for kilometers, and you can detect that in the water, and that allows us to target these vent sites. That's how we find them. If there's a dead vent site, there's no hydrothermal plume. So we have to come up with different ways, new ways. And that's a very active sort of subject of research right now, is how do we find, because we don't know much about them because we can't find them, we don't know, we have a pretty good idea as to how many vents, active vents, there are on the seafloor and their distribution, but we don't have that for inactive vents. So is there 10 times as much material at inactive vents as there are as active vents? The same amount, less, 100 times? We don't know. And but that, so in terms of mining hydrothermal vents, okay, it looks like we're going to actually avoid mining the active vents because we don't want to destroy these very unique ecosystems. So okay, we can then move and target the inactive vents, but we don't know where they are, we don't know how to find them, and we don't know how much of it's on the seafloor, and we don't actually know what lives on them. There's probably a very specialized ecosystem that inhabits inactive vents. We know even less about that than any, the crusts, the nodules, the active vents. Right. So a lot of work to do. Right.
So it seems like unknown, we don't know, is sort of a theme that pervades this whole sphere. Last question I have for Klaas, and then I want to kind of give you guys a chance to, if you have any anything that you want to leave the audience with, like the one point that you wish people would walk away with or whatever. But so the last question that I have for Klaas, which is, given the sort of complicated regulatory structure and all the different players that are involved and who has, you know, power where and when and what, it's very murky in a sense. But let's say that I, not as a journalist, just as a person, let's say that I have a lot of thoughts about deep sea mining and I really care and I want to tell someone in power, who should I talk to? Like, do I call the UN? Do I call my government? Like, who is able to influence this going forward?
Influencing policy or influencing individual decisions. I don't know what exactly would be the question. If you're talking about policy within the international deep seabed regime, of course, everything is vested in the ISA, and the same goes for the decisions. So, well, I hope that it's not that easy to influence those processes, but like I said, within the ISA, the LTC, of course, carries a lot of influence and power, I would say, and that's a body of experts which of course they all have a certain nationality, but they are there. Their function has nothing to do with the country. They do not represent their country in that legal and technical commission, but they, well, eventually you could say they call the shots by making their recommendations, and that composition of the LTC has also already led to some criticism, both the composition in terms of expertise, which is present there, but also in terms of geographical distribution. And so that is still, under discussion right now also, how they would like to solve this. But in terms of exerting influence, well, you would need to be beyond national jurisdiction, deep sea mining, then you would need to be somewhere in the ISA talking to people over there. I hope this is not common practice.
But if I have, you know, the ISA is made up of representatives from member states, maybe if I call the right person, they could call the right person to call the right person to call that person who's then on the council.
So it's ultimately the regulations have to be approved by council, which is made up of member states, as you say, and then approved by the assembly, which are all signatories to UNCLOS. So if you would like to have your voice heard, connect to your representative in your country's government and make your opinions known.
So we went twice as long as we were supposed to, and I'm sorry, it was very interesting. I have a clock on, but I didn't really notice how quickly the time was going. But as we wrap up, I just want to, let's start with John and then Verena and Klaas, the order that we kind of went in. What, in a couple of sentences, what do you want to leave the audience with? What thought do you want to impart on them?
I guess two things. The first one is I like how you, Colin, you emphasized how different these three commodities are. We talk about deep sea mining and we mix all of these together. When you read articles in the paper, they're talking about tube worms and batteries, and you know, those things are, you know, the comparison I make is like comparing wheat farming to chicken farming. Like it's just they're completely different, and they almost have to be discussed and treated separately in order to appreciate all the nuances. And then on a more sort of philosophical note, and this will maybe feed into what Verena might want to say, is, you know, in the end, we need raw materials for society. And there are many ways we can get them. We could reduce how much we need. That's a good start. We can recycle as much as possible. But in the end, we need stuff. And, you know, the question as to whether or not it's better on land or in the ocean, you know, mining is a terrible thing to do to the environment, no matter where you do it. You're digging holes and you're bringing up a lot of nasty stuff. And it's a very difficult question as to what's the right way, until we can start bringing in asteroids, which is ultimately where we need to go, but none of us will be alive when they do that. I think that there are a zillion reasons to not mine the seafloor, and there are probably not a zillion, but there are many reasons to mine the seafloor. And I think what you've heard is that we still know so little, and it's, in the end, it should be comparing apples to apples, seafloor mining versus on land mining, because in the end it's mining, but we have so much work to do before we can get there that we're still at the apples versus oranges.
So Verena.
I'll pick up on that theme.
You might.
At the beginning, John said engineers can do anything. Right now, part of the rhetoric is we have to fuel the green economy, and we have to fuel it from the deep sea. I would suggest that maybe the mining for the deep sea, the metals will come in, and we've got a few decades left before that becomes economically unviable. So you still have a wall. Is the wall here? Is the wall there? Let's get the innovation going now. We have a choice of a trade-off between a long lead time in which we are going to a pristine ecosystems on the seafloor, and mankind has a really lousy record of knowing what it's doing and why and what the results are going to be. I think that given the possibilities that the deep sea floor is already contributing to the stability and resilience of our planetary system, I think we need to get those engineers a whole lot of funding to start solving those apparent iterated problems to fuel the green economy without messing up yet 3 more ecosystems.
And then Klaas, what words of wisdom do you have for everyone?
Well, I briefly touched upon, we briefly touched upon and discussed the concept of the common heritage of mankind. And within the international deep seabed regime, that is the overarching, I would say, the vital concept that binds everything together. And I think the importance of it cannot be understated. There are a lot of components, like I said, and it's very important that all of these get the proper attention and are effectively implemented. Now we see that a lot of those components are still not effectively implemented, or even some of them, like for example, the reserved areas are quite challenged, and that system is getting eroded. So it's very important to keep in mind that the common heritage of mankind, that concept, the legal status of the area and its mineral resources, that we honor that concept, and that all of the components that are associated with it, that they effectively are getting implemented. So that would be my message.
Who knows, maybe the decision that, managing it for the common benefit of all humanity, maybe they'll decide that the best benefit for all humanity, just leave it alone. Who knows how it'll shake out. But thank you all for joining me. I think this was very informative, very enlightening. We might try to follow up with you. There's still a lot of unanswered questions. I might bug you at a different time, but for now, thank you so much for spending more time than you signed up for talking about this with me. And I look forward to talking to each of you at some point in the future when we continue to cover this issue, as it's evolving very rapidly. So thank you.